In this video, we'll be looking at how you construct column graphs. You construct column graphs when you're comparing sets of data. I've only included 2 sets in this, but it is possible to have 3 or 4 different sets. You are clearly comparing data. If you're comparing data, you need at least 10 repeats so that you can carry out a t-test if the error bars overlap. In this video, we will also carry out a t-test and look at the analysis for this. This is data which is made up, however, it is easily collected. Simply compare the mass or the circumference of Skittles, comparing red and green, or whichever colors you wish. There will be differences in them, and then you can carry out a t-test at the end to find out if the difference is significant. You could also compare Skittles with some other type of candy. However, the minimum number of repeats is 10. In this case, I've 18. You have your 2 different types of Skittles, which will be your independent variable, and you have your mass with your precision error included. The first thing you will need to do is calculate the mean mass. You will press equals, begin writing average, and double click average. You highlight the first sample collected, you highlight the last sample collected, you press enter. This gives me the data for the green Skittles. I can do the same for the red Skittles, but it's easier just to drag this over. I also need to calculate standard deviations. So I will calculate the standard deviations for the deviation for the green Skittles first. So it's equal, and again start typing stdev, click on stdev, highlight the first one, ensure that you highlight all of them, but do not include the mean mass, press enter, and your standard deviation is calculated. Drag it across and you have your standard deviation for both of them calculated correctly. However, you will note that the precision of the processed data is 1 decimal point, whereas the precision of the masses, the raw data, is to 2 decimal points as determined by the balance that was used. This means we need to change this to 2 decimal places. Now I need to look at graphing these. When I graph these, the information that I need will be the mean masses against each. I also need to ensure I have the name of what is being compared. So I'm going to create another table below, a very small table, add in the mean and add in the mean. It is important that the precision of these is consistent with above, and it now is. When I want to produce a column graph, the headings of the types of conditions you're included must be included when you choose the graph. So in this case, it's green Skittles against red Skittles, and I have the means for both. I go to insert and I choose a column graph. Just the normal 2D column is fine. You will see red Skittles and green Skittles are present underneath the graphs. I need to add a meaningful chart title, and I will allow you to decide what you want for your graph, but it should include reference to your independent variable and your dependent variable. I need to add axes titles for both the x-axis, the primary horizontal, and the y-axis, the primary secondary. In my case here, it is clearly color of Skittle, which is my independent variable for which there is no unit. The dependent variable, I'm just going to copy this, click here, paste, and the word mean in front. Before I do that, I'm going to make my graph longer. I still need to add my error bars, and I do this using the standard deviation. I click on one of them. One of the columns, you will see both are highlighted. I choose error bars. I choose more standard error bar options. I choose the little column graph. I go all the way down to custom. I specify the value. I click on the error for the positive, and I highlight both of my calculated standard deviations. I press enter. I repeat this process for the negative standard deviation error bar. And I click OK. I should look at these error bars to make sure they make sense. This is 1.96. The standard deviation is 1.42. That should give me just over 3, and it does. This one, it should just give me around, it should be 2 plus 3, so it should be around 4. The data is correct. Do note that as I change these values above, the calculations for everything also changes as well. This is the graph that can be copied and pasted into your report. However, you will note that the error bars are overlapping, and you need to determine if there's a significant difference between these two conditions. It may appear that there's a difference between a mean of 2 and a mean of approximately 2.85. 1.96 and 2.85, but the error bars are overlapping, so you must determine if there's a significant difference between these two means. Be aware that you have a null hypothesis, that there is no significant difference between both groups. Your p-value calculated through a t-test will be greater than 5%, or you accept the alternative hypothesis, there is a significant difference between the groups with a p-value of less than 5%. This is relatively easy to calculate. Again, you're using the functions on Excel. You can insert the function, or you can simply, you can go to formula and insert the function, or you can begin, press equal, type t twice, choose a t-test. And it asks you for the first array. This will be, in this case, the green skittles. It will want the second array. I'll put a comma in, choose the second set of skittles, put a comma in, and then you need to look whether it's a one-tailed distribution or a two-tailed distribution, and we will use a two-tailed distribution here. And finally, you put in the type. It will be assumed that they're paired, and you press enter. It gives you 0.03. This is a decimal. However, it does need to be converted to a percentage. Click on the cell, choose Format Cell, and change the number type to percentage. And click OK, and you get 2.77%. This is your p-value. As calculated by a t-test, it is not a t-value. You now look at this value. Is it greater than 5% or is it lower than 5%? 2.77% is lower than 5%, so I choose the alternative hypothesis. There is no significant difference. Sorry, there is a significant difference between my two types of Skittles based on the data which has been included in this graph. However, if I change the values within this, you will see that the graph is changing. But you will also see that the p-value is changing. It is now at 12.03% as I changed these values. In this case, you would accept the null hypothesis. There is no significant difference between both groups. You can use this method for t-tests in every situation. Don't forget that if, however, you have more than two conditions, you will have to do more than one t-test.